Boys and girls, welcome to our lesson, Form 3, Current Electricity 2. Okay, this is me giving you some tips on how to handle these topics. Okay, the prerequisite knowledge here is you must know what is electric current and what is potential difference. Okay. So those ones have been handled in the previous lesson. So now let us look at Ohm's Law. Okay, this is a German physicist. Let me take you to my clips here so that we can see what is happening. My clips are there. I've just already done them. I want a focus. I want to get the right focus on the yes, that is again losing focus. Just 1 minute. I get it there. I think we can be okay there. At that point, we can put something small for my camera to be stable. I want my camera to be stable, and therefore I have to do some few adjustments here and there. There would be okay for me. Let me see if I can push it to the central. That captures most of the work. Okay. I want the screen to be focused. Yes, I think it is focused, not yet very much. I'm getting challenge on focusing. Let me focus. Then it should be focused then. Okay, I hope you are able to see nicely. Now, Ohm's Law. Okay, Ohm's Law. As I have told you, Ohm's Law, this is an investigation which was carried by a German physicist. Okay? Hence, the law to honor his work. There it is more focused. Now I may continue. Okay? So this German physicist was the first one to carry out some work that related to electric current and potential difference. That's why before you reach to this stage, you must know what is electric current and potential difference. So they were defined to you, okay? Electric current basically is flow of electrons. And the potential difference is what facilitates that flow. In other words, even if I have a complete circuit with the switch on, but there is no potential difference, then there is nothing that will drive electrons round in that circuit. So this Mr. Ohm, Simon Ohm, studied what is the relationship between these two quantities. Okay? So in a nutshell, this is what we are heading to. That the current that flows through most conductors is directly proportional to the voltage applied to it. So when we talk of a conductor, what do we mean? A conductor is just a piece of wire. We can have a nichrome wire. We can have a copper wire. It is basically a wire that allows current to flow. Okay? Sometimes in a special way it may be called a load with respect to it being the central or the focus of your experiment. It is a load. Okay, so that is the introduction I want to give you. Our mind should focus on the relationship. So the core business we are doing is the relationship. Okay. Number two, if I am asked to state Ohm's law, how will I state it? Ohm's law states that the voltage across a conductor is directly proportional to the current flowing through it. That is the relationship. Okay? That the voltage and the current, they have a relationship. When we take a particular conductor and get the voltage across it and measure the current flowing through it, then they are directly related. What is example of direct relationship? As the number of days increase, so is the height of the plant or the height of grass. As the days go by, also the plants grow tall. That is a direct. We can have direct relationship in the opposite way, in the sense that if one quantity is decreasing, the other one is also decreasing. So the two quantities are said to be in direct relationship if either both quantities are increasing or both quantities are decreasing. But in experiments, there are some constants. There are some factors that are made not to change. That this experiment or this law abides if the physical conditions and temperature remain constant. We shall focus on temperature. That if temperature does not change, then the voltage is directly proportional to the current. Okay? So we have fixed the temperature so that it does not affect our study on electric current and voltage. Okay? So remember, when you are told to state the law, you give the relationship and the condition under which the law holds. Without that condition under which the law holds, you cannot score. Otherwise, it is only 1 mark. So mathematically, what do we do then? Mathematically, we say that the voltage is proportional to current. Either both can increase or both quantities can reduce. In Form 3, we learn this is a symbol of direct relationship, and if we want to replace it with equation, equal sign, you introduce a constant. This is a mathematical norm. This constant K is known as resistance of the wire or of the load, where the load, or in simple terms, the wire under study. You are studying a particular piece of wire. So that is what I may call the load now. Okay? So I replace the constant K with acceptable letter in physics, letter R, which stands for resistance. And therefore, my equation now, mathematically, is V is equal to IR. Remember, Ohm's law only holds true if the provided temperature and other physical factors remain constant. Okay, that one I have said, so I don't need to dwell there again. It was just to remind you. Then here I have tried to write for you the letters and what they mean. Voltage. V is the voltage across the conductor. Remember, it is the voltage across the conductor. And I left the units, so it is measured in volts. Now remember, the conductor is the center of our study. Let me give you an example. Maybe I use the bulb as the center of our study. Therefore, the voltmeter has to be connected across the bulb or the conductor or the specific wire. I is the current flowing through the conductor. Current flows. Okay, that is a good terminology to use in this topic. Okay, not current moves, but current flows. Okay, R is the resistance provided by the conductor to the flow of current. In your own time, find out the voltage, the SI unit of voltage, of current, and resistance. So that is assignment number 1. Here is what we want now to dig deeper. We want to see, we want to verify, and we want to record and possibly to draw a graph which will help us agree with him or not. Okay? So, what are we saying here? We are saying, what requirements will I need to try and verify the law? The law exists, we have to verify. So, there are some requirements that you will need here. You will need cells. And what will be the function of the cells? You will write and complete the following. Cells to provide what? Voltmeter is required to measure what? Ammeter to measure what? What is my load like? Is it a nichrome wire or is it a bulb? That is, remember, the core of what you are trying to study so that you can say, yes, Ohm's law is true. We are applying some variables on the load. We are trying to understand what is the behavior of this load when voltage is measured across it and when current flows through it. Ammeter is connected in which format? Is it series or parallel? Same thing, you will tell us. Voltmeter is connected in which format? So that will be activity 2. In your own time, you get the units, I've said that. And 2, you complete the sentences, just in short form, 1 or 2 words only. Okay, so don't make stories here. This is just to remind you and prepare you for the experiment. So you will find out the answers when you go to another clip. Okay, boys and girls, this is the new phenomenon in the 21st century skills, that you may not have a lab per se, but you can carry out experiments using animation and simulation. Okay? So in the virtual lab, which I will introduce you to just now to show you what it is, so that next lesson we shall use it to verify, you need a set to set the apparatus as shown in the diagram. So you have a diagram which requires some apparatus. We will show you the skills of setting the experiments. In that experiment, we shall vary the voltage and record corresponding values of I. These ones will be tabulated using 3 columns: voltage or potential difference in voltage, bracket V, then current I in bracket amperes, and then you will have a third column. For each set you take V and divide by its corresponding current and leave it at that. The units will be V over A. After that, we shall draw a graph of V against I. Okay? I want you again to explore the units of V. V for voltage and I for current. What are the units that will accompany those quantities? From your table, is it possible to have an insight on the nature of the expected line? Then I will require you to draw the gradient from your graph. Remember how to draw the best line of fit, and then we shall make conclusion whether Ohm's law holds or not. Okay? As I finish, this is the circuit that we shall use. Okay? So you will have an ammeter, you will have a bulb, you will have voltmeter, you will have a source of PD. Okay? So in our next lesson, we shall pick it from there. So it is important that you draw this circuit, answer the areas that I've asked you to do. I can remind you, 1 was the units. Okay? Number 2 was to complete the sentences on the clip. And number 3, as you draw the table, I've said V against I. We want to remember which axis carries voltage and in which units, and which axis carries current and in what SI unit. Folks, I stop there. We meet next lesson, lesson 2, using virtual lab. Bye-bye.